There is a moment, just before sunrise, when the Atlantic is so still it looks like poured steel. The crew on board the drone ship has seen 1,000 of these mornings. They've watched Falcon 9 boosters fall out of the sky like silver needles and plant themselves on the deck, again and again, until it stopped being a miracle and started being a job. But this morning is different. This morning they are not waiting for a booster. They are waiting for something the size of a building. Let me take you back a little, because to understand why anyone would even think of doing this, you have to understand the problem first. For years, the entire dream of Starship rested on one idea, the catch: no legs, no drone ships. Just a colossal rocket falling back toward Earth, and a tower named Meshazilla, reaching out two enormous arms to grab it out of the air. It was elegant, it was insane, and it was the whole point. SpaceX never wanted Starship to land in the old sense. They wanted it caught, refueled, and flying again before the launch pad even cooled down. So why would they ever go back to the ocean? Why bring back the drone ship era that Falcon 9 was supposed to leave behind? The answer is hidden in one quiet, growing problem: numbers. The plan was never one launch or 10. The FAA had already cleared the way for up to 44 Starship and Super Heavy launches a year from a single pad in Florida, and with them, 88 landings every 12 months. 44 boosters down. 44 upper stages down. All of it funneled through one tower. And here's the thing about a single point of anything. It works beautifully right up until the moment it doesn't. One Mechazilla tower for every single launch and every single catch isn't a system. It's a bottleneck waiting to happen, and Starship is not Falcon 9. When it lifts off, it isn't just bigger, it's roughly 10 times louder, a wall of acoustic energy that shakes the air for miles. You cannot run that again and again without giving the whole machine somewhere else to breathe. So somewhere in a room full of engineers, an old idea came back from the dead. The drone ship. On April 21st, 2026, a vessel called Just Read the instructions completed its 156th Falcon 9 recovery. For most of the world, it was a footnote, another booster, another deck, another quiet success. But inside SpaceX, it felt less like an ending and more like a graduation, because that drone ship wasn't being retired. It was being promoted from catching small rockets to serving the largest launch system ever built. The Falcon era was closing. The Starship era at sea was about to begin. The plan that emerged wasn't what most people imagined. Forget the dramatic picture of a floating Mechazilla tower bobbing in the open ocean, too heavy, too complex, too expensive to ever be practical. The real idea was simpler and far more cunning. Most Starships, around 90% of them, would still be caught by towers, because nothing beats a tower for speed, but a small specialized fraction, maybe 1 in 10, would be fitted with something Starship was never designed to have: legs. Now, the moment you say Starship landing legs, anyone who knows rockets winces. And honestly, they're right too. This is not Falcon 9's landing gear scaled up. It can't be. The numbers don't just grow. They change category entirely. An empty Starship upper stage can weigh around 5 times more than a bare Falcon 9 booster. Falcon's legs were built for something lighter, narrower, gentler on touchdown. Starship lives in a different universe of mass. Then there's the fire. Falcon 9 settles down on a single Merlin engine. Starship is expected to land on 3 Raptors, throwing nearly 840 tons of combined thrust at the deck, close to 10 times the force of one Merlin slamming into steel at the instant of touchdown, so the real challenge was never holding the rocket up. It was absorbing that violence, that skyscraper of metal coming down hard, while the platform beneath it refuses to stay still, rolling with every Atlantic swell. The engineer's answer was almost brutal in its honesty. 6 massive legs spread across a footprint, maybe 15 to 18 meters wide, a stance broad enough to stop a 160-ton vehicle from tipping while the deck heaves under it like the back of a breathing animal. But geometry was only the beginning. Once Starship got this big, it stopped being a shape problem and became a materials revolution. Falcon 9 could afford delicate things, lightweight carbon fiber, honeycomb cores, the elegant solutions of a smaller machine. Starship burns those options away. At this scale, lightweight stops being the goal. Survival does. Strength, heat tolerance, fatigue life, the ability to build it 100 times without it failing. That's why a serious Starship leg wouldn't be made of feather-light composite. It would be forged from stainless steel, the same stubborn family of alloys that already forms the ship's skin. Carbon fiber wins on weight, yes. But steel wins on the only thing that matters when a rocket is falling toward a moving deck: raw, unglamorous survivability. Chilled to cryogenic cold, those alloys can nearly double their strength, letting engineers build thinner walls that still refuse to bend, and there's the heat. By the time these legs deploy, the surfaces around them may have just lived through temperatures above the 13,400 degrees Celsius. Carbon fiber starts dying long before that. Steel doesn't flinch. It even grows its own protective oxide skin. No fragile heat shield coating required. But on the side facing re-entry, even steel needs help. Those legs would have to wear heat shield tiles like the rest of the hull. In other words, the landing legs wouldn't just be legs. During the worst minutes of the descent, they would become part of the heat shield itself. This is the part the public never sees, the part that keeps engineers awake. These legs have to fold up and disappear into the aft section of the rocket, a space already crammed with engine bays, propellant plumbing, the tangled iron heart of the machine. Carving out room for folded legs in there, without disturbing the aerodynamic skin, without leaving so much as a bump that could turn into a blowtorch of localized heating during re-entry, is its own quiet nightmare. And then comes the question nobody wants to ask out loud: what if a leg doesn't retract? A single leg stuck out where it shouldn't be becomes a point of turbulence. Turbulence becomes a spike of superheated plasma. Plasma finds the gap around the landing gear bay and pours in toward the piping, the engines, the fuel. That isn't a bad landing. That's the loss of the vehicle. So the retraction system can't just work. It has to work every single time, which raised the next question: how do these legs even move? Falcon 9's legs are simple by design. Nested hollow cylinders shoved into place by pressurized helium, locked by mechanical latches, one-shot devices that ground crews have to manually reset before the booster flies again. For a rocket meant to land, refuel, and launch with almost nobody touching it, that's unacceptable. Starship's legs have to extend and retract themselves on command without a crew babysitting them. The proposed answer traded those pneumatic tubes for hydraulics, enough raw muscle to throw a 160-ton vehicle's weight around and pull the legs back in afterward. But hydraulics fear the vacuum of space. A single leaked line on a long mission is a disaster. So electric actuators entered the conversation. Less brute force, but steadier, more predictable, indifferent to the temperature swings that make gas pressure lie. The kind of reliability you need when the same machine has to do this hundreds of times. But say everything works. Say the legs deploy clean and the rocket comes down true. The story still isn't over. In some ways, it's just beginning. Because that drone ship is not still. It is rolling, pitching, rising, and falling with the moods of the Atlantic. And Starship, tall and top-heavy, isn't a booster. It's a steel skyscraper balanced on a deck that won't stop moving. The mission doesn't end at touchdown. It ends when the rocket is secured. And securing it would take something far beyond the simple grabber robots that pin down Falcon 9. The first priority is a lock that fires the instant the legs feel the deck. One concept is almost violent in its directness: explosive-driven pins or anchors that punch into sockets the moment sensors confirm the rocket has landed, welding the vehicle to the ship in seconds before the sea can slide it across the steel. An even more extreme idea borrows energetic welding, a technique that uses an explosive charge to slam a metal bonding layer into the deck so fast it creates a true metallic bond, a footpad that in theory welds itself to the ship the instant it touches down. It is genuinely one of the coolest things you could ever watch. The largest rocket ever built, kissing the deck of a ship in the middle of the ocean. And it goes against everything Starship was supposed to be. Here's the hard truth SpaceX has to live with. They don't just want Starship to land, they want it to fly again, fast. And legs fight that dream on every front. There's the dead weight, a robust leg system with all its actuators and internal reinforcement could add dozens of tons of inert mass, quietly stealing maybe 10 to 20 tons of payload from every single mission. There's the turnaround, a rocket pulled back from a distant ocean, sometimes weeks of slow transit across open water, then inspected, cleaned of corrosive saltwater, reset. Compare that to the tower catch, which sets the booster almost directly back where it started, ready to be restacked. The difference isn't a delay. It's the difference between a rocket and an airplane. That's why legged starships would never be the standard. They'd be a small specialist subfleet, a tool for the missions that need the ocean, and some missions truly do. When a super heavy pushes a heavy payload toward orbit, it burns roughly 90% of its fuel just on the way up. Asking it to flip around and fly all the way back to the tower means hoarding fuel it could have spent on the mission. Let it land downrange on a drone ship instead, and it can pour nearly all its remaining propellant into the payload, keeping just about 1% for the landing burn. That isn't a small gain. That's the difference between what you can and cannot lift into orbit. And then there's the lesson history keeps teaching. During one early Starship test flight, a problem forced the booster into a water splashdown, destructive, unrecoverable. With crew aboard or priceless cargo that can't be the answer. A drone ship turns a catastrophe into a redirect. It means a single damaged tower doesn't stop the whole program. It moves the thundering, ground-shaking landing burns far out over open water, away from people, in line with what the regulators and the coastline can tolerate. The same logic that has quietly carried hundreds of Falcon 9 landings to sea. The ocean, of course, does not care about any of this. SpaceX learned long ago that you cannot fully tame a drone ship. 4 powerful thrusters tied to GPS can hold the barge's position on the map, but they cannot stop the sea from tilting it, lifting it, dropping it. Instead of fighting the water with expensive motion-concealing systems, SpaceX chose something humbler: ballast. Flood the ship until it sits low and heavy, let sheer mass blunt the worst of the roll, and simply live with the rest. For Falcon 9, the rest was survivable. For Starship, the margin is razor-thin. Elon Musk has said a booster needs to be within about 10 degrees of straight up to stick a landing, and rough seas can already tilt the deck 3 degrees on their own. That small wobble eats into a margin that was never generous. A single badly timed heave at the moment of touchdown could let those legs lose their grip and send the rocket sliding. The way early Falcons sometimes tipped and died, with Starship's greater mass and higher center of gravity. That isn't a hard landing, that's a fireball. So the strategy shifted again, not toward smarter machines fighting the sea, but toward sheer, stubborn size. The next generation of recovery ships would likely be twice as large as today's barges, approaching the displacement and steadiness of an aircraft carrier, big enough to simply ignore the smaller waves that would throw a lesser vessel around. And that is when this stops being a story about landing a rocket and becomes a story about building an empire of logistics. Over 100 launches a year planned out of Florida. Landing zones scattered across the Atlantic, the Pacific, the Indian Ocean. A recovery from the Indian Ocean alone could mean weeks of slow voyage home. To keep an airplane-like rhythm with that kind of distance, SpaceX would need a fleet, at least 8 dedicated vessels feeding 4 landing zones, an endless relay of steel coming and going. The drone ship would stay on station, already waiting for the next arrival, while separate transport ships handled the long ferry home. And because Starship is too vast to ride upright across an angry ocean, it would be tipped onto its side with a breakover fixture and carried horizontal, a mechanical necessity to survive the wind and the endless wave-borne shudder of a long voyage. Eventually, those transports might carry several boosters at once, an assembly line moving across water. It is not a simple thing. These recoveries cross international waters, brushing against the economic zones of distant nations, demanding diplomacy and careful timing through the world's busiest shipping lanes. And every mile of the way, the salt air gnaws at the steel and the vibration works at every joint, the hardware monitored constantly to make sure it comes home whole. By 2026, this maritime web is meant to reach maturity, The drone ship transformed from a humble recovery barge into the central nerve of a global transportation system. And here, finally, is why the engineers find this stage so quietly thrilling. Everything they are solving in the cold chaos of the North Atlantic, the self-reliant hardware, the punishing distance, the absence of any help when something goes wrong, is a rehearsal. The exact same problem, scaled up, is what it will take to connect Earth to the towerless wilderness of the Moon and Mars. Every tile that has to survive the searing plasma of re-entry before a single-legged Starship can even attempt the sea. Every system that has to fend for itself when rescue is impossibly far away. By forcing these vehicles to endure the harshest places on Earth, SpaceX is stress-testing the very machines meant to carry humanity somewhere far less forgiving. So when that drone ship crew stands on the deck before sunrise, watching the horizon for something the size of a building falling out of the sky, they aren't just waiting for a rocket to come home. They're watching the rehearsal for the day we leave home entirely.